Once again, hello. Welcome back to AKM Analytics, where we empower data-driven decisions. My name is Esdras Koome. This is the second and the last bit of simple linear regression model where we shall be conducting coding in R. First step to performing simple linear regression model in R is importing the dataset. So we can either use inbuilt functions or functions from contributed packages in R to import data. So I'll store my data set into an object that I'll name customer data. And then I'll use the read.csv, which is an inbuilt function, to import my data because my data is a CSV file. Customer, my data is named as customer data. So customer data.csv. You can see my dataset is loaded. Now, to perform the simple linear regression model, since we have already imported the dataset, we shall say model, which will be the name of the object we want to store our model. Model is equals to lm, which is the function that is used to perform simple linear regression model. Then you specify what is your y. My y is customer registered. That is what I want it to be, my y, or my dependent variable. And then customer data addressing public awareness, that will be my x. Remember, we discussed this in part 1 of our video, so if kindly you have not watched part 1, do so, so that you can be able to understand even the interpretation. So we run the model and the model is loaded, and then we get the summary of our model. So here we already have the summary of our model, and that is it. From the summary of our data, what we have to identify here is our B notes and our beta 1. Recall what we discussed in part 1. Y is equals to beta note plus beta 1 x plus the epsilon. So our beta note is the y-intercept, and our beta 1 is the slope of our equation. So from what we will be able to identify here, we can see the intercept, the value under intercept, that is always our beta note, and our beta note here is negative 10.5. Then we have to check from the p-value, is our intercept significant? Yes, it is, because the p-value is equal to 0. So 9.59 exponential negative 9 is similar to 0. We then check the beta 1, which is 4.10. So our beta 1, is it significant? Yes. From the p-value, we see that our beta 1 is significant. So our equation is equal to y is equal to negative 10.5 plus 4.1x, or customers is equal to negative 10.5 plus 4.1 star number of campaigns conducted. From the summary of our model, the other thing we identify is the amount of variance of y that is accounted by x. If you recall, on our past video, we said if a model accounts 25%, then it's a good model. So what do we use to identify this? We use the multiple r squared for simple linear regression model. So from this one, you can see 99.28% of variance of y has been accounted by x. And now, from that, we check whether our model is satisfying conditions for simple linear regression. And to check that, we do the diagnostic plots. And to plot the diagnostic plot, we have to do this. RMF row is equals to compile to the number of rows and columns, and then we plot our model, our four diagnostic plots. So our diagnostic plots are already here. And from the first diagnostic plot, here, remember we discussed that we use this to identify for linearity. And if you see there's a curve, hence you can say there's a bit of nonlinearity. On the second one, here, remember what we discussed also? We use the QQ residues diagnostic plots to identify for the normality, whether the residues are normally distributed. And you can see most of them are lying on a straight line. Hence, we can say they are normally distributed. On the third one, we use this one to identify for homoscedasticity invariance. And you can see there's a bit of a curve. Hence, we can conclude there is some heteroscedasticity. And on the last one, we use it to identify for influential factors or outliers. And from what we can see, the points do not seem to lie far much from the red line. Hence, we can conclude that there are no influence of outliers, no influential factors. So that is it. Thank you for your time. See you on my next video, where I'll be discussing about multiple linear regression model.